Hello everyone. Good morning, good evening, good day, whatever time it is for you right now. Welcome back to the stream. This is entry number 2 in this stream series. And if you didn't catch the last stream or know what this is about, basically we're working on a simple platformer game using the MonoGame framework. Really simple project, and basically it's supposed to be somewhat of a community project where everybody can make suggestions, throw in some ideas, whatever. Basically all we want to do here is have some fun and create a small little game completely from scratch, actually using pre-made assets, because I really don't feel like creating assets myself, and I'm actually not quite good at it. So that's the plan. And the last session was actually pretty great, so I figured let's continue. We'll just wait another minute or two for people to join, and then we'll just dive right in. Oh, but before we go any further here, please do me a favor and let me know if the audio setting is okay for you, if the video quality is okay. And actually for that, let me remove the title card here. There we go. You should now be able to see the IDE. So if the quality sucks for you, then just let me know. But I didn't change anything about the settings, so it should still be just as good as it was last time. Hi there, Freetime FM. And hi there, Brother Noctarion. So yeah, we're just gonna continue right where we left off last time. So last time we did just the very basic stuff. We implemented sprite animations. We implemented sprite animations and got the basic player controls down. And let me just show you. It's really simple because basically we start with just the very basics. So far all we can do is control our little animated character here and throw some punches or swing our sword or whatever. And sometimes he makes this really awesome noise. Hold on. Come on. There it is. Woha! I love it. Okay, so basically all we did last time was create the sprite animations and get the controls down, like I said. Build a basic entity framework that we can use in the game to add objects to the game world and remove them and stuff like that. Some utilities, and that's basically it. And this time basically what I want to do is first of all implement the physics using some physics library, probably Farseer. I was thinking Box 2D, but in my last project I used Farseer and it turned out pretty well, so I think that's what I'm gonna do today again. Hi there, Danielle. Good to see you. So yeah, we're gonna use Farseer most likely. So let's actually go ahead and add the dependency here. Whoops. And there it is. I think that's the one. Farseer Physics Engine is a collision detection system with realistic physics responses. Yes, you heard that right. Our very simple ninja game is going to have realistic physics responses. Not really though. Oh yeah, I remember this. Problem with this is that in the Farseer assembly, it was done with good intentions, I guess, but what they did is they also created like a vector 2 struct, for example, that uses the exact same namespace as the as in the MonoGame framework, because they wanted to make it compatible, but it just creates ambiguities. But I think we can alleviate that by simply creating an alias. Hold on. Oh, hi there, Nightbird. Glad you could join us. So we're going to work on physics today. And also I want to refactor this state machine, which I forgot to mention earlier. We also implemented a state machine, a reusable state machine, for controlling the different player states. And I wanted to rework that a little because I don't like how it's currently done. It's going to be too much of an effort later on, I think. So I'm going to refactor that just a little bit. Just there. So yeah, since we have now some ambiguities here because of similarly named namespaces, I'm going to have to add an assembly alias. And that's not something you do every day, so let me just... Hold on. I think you can just go into the properties of the project. Where is it? Ah, come on. Oh. Oh yeah, right. I think we just have to go here in the DLL. And then it should be here. You should be able to... Oh, where was it again? Does any one of you remember how to add an alias for an entire assembly? It's not something you do every day. Should be here. Should be in the property tab. I mean, if all else fails, we can just use an alias up here in the using directive, but you can do it globally. Hi there, Pizzlify, is that correct? My day job is actually I'm actually a developer. Mostly .NET, but other stuff too. Where was it again? Yeah, like mostly full stack web development, but all kinds of stuff. It depends on. Basically, I work as a consultant for a consultancy company, and I get assigned to different projects as a developer. So it always really depends on the project. Where was it again? This is embarrassing. I don't know why they did this. So basically what they did, the people who created this Farseer physics assembly or library, they named all the namespaces, or some of them, exactly the same as in the MonoGame framework. So obviously that creates some ambiguities. Have you worked as a game dev before? Or game dev is basically just a hobby. I've never worked on a commercial game or something. This is just what I do for fun. Usually I mean, if all else fails, we can also use box2d. Well, let me unload this. Reload it. Actually, down here it should list the aliases. I don't know why it's not there. Box2d is more easy than Farseer. You think so? You mean, yeah, I don't think so, but let me see. No, you can't auto-resolve this. I mean, like I said, I can just... remove it. And use box2d instead. Yes, that's a possibility, but I would have liked to work with Farseer because I've worked with it on the last project. Hold on, let me just a second. I think we can simply, let me just install Farseer again. And now just simply edit the project file. And I think we can just manually go here and say alias. Oh, that's the wrong one. This might work. Well, never mind then. We'll use box2d. Doesn't really matter. But what do you mean box2d is easier than Farseer? How so? Okay, but if we're gonna use box2d, I will have to pull up the documentation because I haven't worked with it too much. And I think the documentation is actually for the original C++ implementation, but we should be able to adapt that. Okay, yeah, I think it's actually very, very similar to Farseer. But let's see. Let's create a folder, call it physics. I'm gonna create a class in there named physics manager. What's the namespace of box2d? I think there's something wrong with this package. Let's use a different one. There seem to be different implementations here. Port of box 2D. Box 2D C# port. This package supports .NET Standard. This one is at version 2, so I guess it's maintained more frequently, so let's use this one. What's wrong with this? Was restored. This is the .NET Standard library. Why does this target .NET Framework? I think there was a .NET Standard one. So I guess today we're having some trouble getting started, but it happens. Whoops. It supports .NET Standard 2.1, but we're at .NET Standard 2. So this is why I wanted to use Farseer. Because it worked perfectly fine for my other projects. I mean, we can use a DLL instead of a NuGet package, but that's kind of lame. So what do you suggest? Problem is that this NuGet package targets .NET Framework, but we're using a .NET standard library. So that's a bit of a problem. I guess an assembly binding will actually make that work, but it's kind of cumbersome. Let's see. So let's see. Let me just test something here. Okay. And I think we need to create a physics world, right? Well, or just world. Yeah. Okay. Yeah, it's very similar to Farseer. I mean, it's unfortunate that we use a package that is actually meant for .NET Framework and not for .NET Standard, but I guess it'll do for now. So let's see. Basically, we need an instance of this world class from Box2D, and our physics manager will just create one as a field. Let's check the documentation. So we need to create a world. Define gravity. Okay, but the constructor here. Is there like a static method for creating it? No. Okay, it wants an axis-aligned bounding box. I don't know what for. Maybe it's the bounds of the entire world. Probably. Lower bound. Say like, oops. Wait. Yeah, I don't know what these bounds are for. It's not in the documentation. It's probably just the boundaries of the entire world to basically limit the physics simulation to a certain area. But I don't know for sure. And it's not in the... I mean, it's probably in the documentation, but not in this one. Here, all they need to pass to the constructor is the gravity. So maybe let's just create a huge bounding box. So you need to bear with me here since I'm not using Box2D every day. So let's just say minus 1000 and minus 1000. For now, it's just for testing for now. Oops. And here we're going to go with positive values. Pass the box here. So if any one of you has more experience with Box2D and just knows some tips, let me know. I don't work with it every day, so... So the gravity, I guess we should make a property of the physics manager. And I will work with the MonoGame vector 2 here. Because I don't want to expose... Basically what I want to do is create some wrappers around the Box2D classes. So instead of using world directly, we're going to use this physics manager, and it's just going to wrap all of the Box2D behavior inside. So that the rest of our game logic doesn't really know about Box2D. It just knows about a physics manager, and it knows about colliders and stuff like that. That wouldn't be a great help here. Never used it, yeah. No worries. I mean, it's very similar to Farseer already, but not quite the same. And I was actually hoping to use Farseer. And I completely forgot about this issue with the namespaces being identical. Do sleep, I guess false. Let's add a property here. And probably, I assume, that the world also exposes a gravity. Yes, it does. Oops. Oh yeah, actually, I do want this. So, like I said, I'm basically creating a wrapper around, around Box2D to simplify it. Because I don't want to deal with rigid bodies and stuff like that. I know it's really powerful, but it's just a simple platformer. So we're going to basically abstract it and simplify it so that we basically only have a physics manager and colliders. And that's it. And maybe triggers. So we have a physics manager that takes care of creating colliders and making and checking if they collide and stuff like that. And we have colliders that actually resemble the hitboxes and stuff like that. And triggers for checking if some things overlap, stuff like that. Okay. So we create a world, pass the gravity to the constructor, that's fine. And I think there is also some sort of utility method for setting the calculation for how many units in a pixel and stuff like that. I think. Let me check. Nope. But maybe the world... Because there must be some sort of conversion between pixels and units in the simulated physics world. There needs to be some sort of conversion. And I think in Farseer there was like a static property for that. But I don't think that's how they did it here. Not sure. Maybe I have to look it up in the documentation. It doesn't seem that way. But let's just follow the documentation for now. Okay, so we can create bodies. I think we need to use the world to create bodies. Yeah, so we can create rigid bodies, which basically resemble a moving body within a simulated physics world. And use those for, simulating physics. And I want to wrap those around, or not around, but I want to wrap those in an actual class. So let's do that. I'll create a class here and call it Collider. And the collider will just be a rectangular box in the world for checking collision detection. For doing collision detection. It needs to have a property of type rect. Rectangle. And here in the constructor, what we will do is pass the rigid body, I guess, from box to D. And then we'll just store that in a field. But I guess the smartest thing right now is would be to just implement some sort of test, just to make sure that we got things in order. I will delete this method later on. Let's just say world. Create body, new body def. Oh, that's a whole lot of properties. Is bullet fixed rotation? It's actually quite simple. Mass data, position. Oh, okay. Well, that's good to know that there's a position property. We can use that in our collider. We can just go public vector2 position. And it will just return the position of the body. But we'll obviously have to convert that into an instance of the vector2 from MonoGame. And I guess we can also have a setter. Nope. You can't set the position directly. Well, then never mind. Allow sleep, let's say false. So they create a body definition. And they call the create body method, pass the body definition, and it'll return a new body. Then create a shape. Okay, I got it. Well, let's put this outside here. And I guess we don't need all of those properties. Let's say maybe 10, 10. I don't know what units this is measured in. It's probably simulated meters or something. But like I said, I don't know the conversion between pixels and meters. And there must be a way to set the pixels per meter and stuff. So now I need to create a shape. And let's just go with a box. And a box is basically just a polygon, so... Wait, do we call the constructor directly, or...? Guess so. Well, I think actually... Nope. We can't call the constructor, obviously. So it's probably an internal constructor. And I think I remember this from Farseer. They did it similarly. You can't actually create the shapes directly via constructor. There was another way, like a factory or something. Let me see. Actually, go. Whatever. That looks like a different thing. Nah, let's just stick to the official. I mean, obviously it's an unofficial C# wrapper, but it should be very similar. come on. Oh, yeah. And now I can use the test body to create a shape. Yeah, there we go. But I need to define the shape first. That is correct. Yeah, oh, yeah, here's a Boolean property is sensor, which we can use for creating triggers. So basically like hitboxes and stuff. So they're not actually, they don't simulate collision, but they simulate, basically they check if things overlap. So I guess we need to set a density. Let's just use 1. And I don't know what kind of music this is. Let me just... It's annoying. Oh, that's better. Okay. So let's create a shape, pass the shape definition, and it'll return the shape. But then how do we tell it that this is going to be a rectangle? Oh, there's no such thing. Is it maybe determined by the properties here? Restitution type. It's probably an enum. Yes, it is. Ah, there we go. So we can tell it that it's a polygon shape. Okay, so basically this is a factory method, and we just pass this definition, and if we pass a definition where the type property is set to polygon shape, it'll actually create an instance of polygon shape. Friction, we don't need that. Filter is, I think, for determining like what different types of objects should collide with each other. For now, we don't need that. I think if you don't set a filter, it just basically assumes that everything collides with one another. So that's fine. And I think we need to add a fixture. But I'm not sure, but I think in Farseer, what they did is they included the fixture creation logic in the shape creation logic, I think, and this might be similar. Not sure. So there's no way for me to create a fixture. Anyway. Let me just hold on. There could be. No. Not sure how they implemented the fixtures here, because I don't even see a fixture class. So they might not even have included those and kind of implemented it differently. Never mind. Okay, so we need to update the world. So our physics manager will need an update method. DT is the delta time, I guess. Yeah, very obviously is the delta time. So we can just pass the total number of seconds that have passed. Velocity iterations. I guess this is the higher the value, the more accurate the simulation. Here they use 6 and 2. For this simple example, we don't need much iteration. Suggested iteration count for box ID is 8 for velocity and 3 for position. You can tune this number to your liking. Just keep in mind that it has a trade-off between performance and accuracy. Yeah, let's go with 6 and 2 as well, because I don't think we need that much accuracy. And for now, we'll just hard code that, and then later we will clean it up a little bit. Double to float, yeah, okay. Let's call it create test bodies. Let's think of a way how we can make the bodies visible for the test. I guess we could just implement a simple, oh yeah, I think I know. Okay, let's do it differently. Actually, I'm not gonna remove this, but hold on. Just bear with me. So we're going to have like a factory method here that creates instances of collider. And in here we will add the body to the world and stuff. So let's just say I guess angle will be 0 by default. Let's see, is bullet. I guess it's false by default, right? So what do we actually need? Okay, I got an idea. So I'm going to create an interface called iTransformable. It's going to expose a position and here in the physics manager you can pass a transformable because there's a user data property which is of type object, and you can pass anything there just to basically create a coupling or a reference to a different object. So the mass, yeah, that heavily influences the... Alright, have to go. Have a nice stream. Yeah, thank you, Nightbird, for stopping by, and have a great evening. So the mass data obviously heavily influences the behavior in the physics. So let's just pass it here. Is it not a float? No. Center, mass. Okay. For simplicity's sake, we will just have the center always be the center of the object. Oh, come on. What type is center? It's a vector 2. What's the other? I? It's I. No. Maybe let's skip this for now. Angle will be 0. False. Position will, I guess, be position of the transformable. Fixed rotation. I guess in our case we will always have the rotation be fixed. Maybe we'll change that later, but let's just set it to fixed now. Yeah, and I guess the rest we can just leave at the default value. So the type will always be polygon. Density, let's just set it to 1 for now. Sensor in this case is false. Restitution. We don't need friction for now. Okay, and now we will just pass that. Wait, I guess, hold on. I guess the body should already, yeah, it already has a list of all the shapes in it. But anyway, let's pass the shape here as well. Generate a field. Now, how do I determine? I mean, we said here it's a polygon shape, right? But so far we weren't able to tell it what size it's going to be. So I wonder how we can do that. I don't think there's a property here for that. Is there a separate overload here? No. Compute AABB. There's an out parameter. Compute mass. I mean, this can't be it. We never told the body or the shape the size of the polygon. So how is it supposed to know? Does the body have like utility helper methods or something? Get position. Set X form. Put to sleep. Get position. It should be the shape, right? Whoops. But there's not much you can do with the shape. Why is there no documentation for this C# binding? I also think it's really weird that we never create a fixture. So usually what you do is create the body, then create the shape, and then create a fixture from the body. So how are we supposed to, first of all, let's return the collider here. Hold on. No. No separate overload. Oh, is that what the mass data is for? Nah, that can't be it. What's I? I mean, the mass is the mass, obviously. The higher, basically the heavier the object is. But yeah, and the center is basically like the center of rotation. But what is I? Rotational inertia. Okay, we don't need that. Position of the shape's centroid relative to the shape's origin. Mass of the shape in kilograms. Should never be negative, yeah, obviously. So this is the reference of the original C++ implementation. So it's fairly different from our C# binding. How do we tell it the size? I don't get it. We can compute the axis aligned bounding box. That's a different thing. Get body. It's weird. You'd think it would be in the shape definition. Okay, so this is the repository where of the Box 2DX project. We have a couple examples. That's great. Perfect. Okay, so yeah, that's actually the bounding box you pass to the world is actually just the general bounds of the world. So that's correct. And define a gravity, blah blah. Do sleep true? Do we want to let body sleep? New world. Ground body def. Polygon def. Oh, there's a polygon def, which is like a subclass of shape def. Whoopsie. Yep, okay, never mind. So let's just follow the example here. Polygon def. Ground shape def. And then you can just call set it. Okay, that's just perfect. Okay. Okay, got it. I don't even need to do anything here. Just there, and then just go polygon def, set as box, and then I can pass the height and the width, I guess. And for that, we'll pass here a vector 2 size. Whoops. Okay, what's this Star Wars like music? So yeah, this this time around in this stream, things weren't going quite as smoothly as last time, but hey, what can you do? I don't usually, or let's just say, last time I incorporated a physics engine, it was Farseer, which was very similar to this, but not quite the same. So now we can just pass the polygon def because it's a subclass of shape def. There we go. Create the collider. I guess technically we don't need to pass the shape because it's included in the body. But let's just keep it like this for now. And there should be a way to tell the physics engine how many pixels there are in 1 meter. Set the density to be non-zero so it will be dynamic. Okay, so first create, so they first create a ground. Okay. Body. Do they just use one body here? No. It's a ground body and another body. Okay. Go. And there must be a way to tell the physics engine if it's a dynamic body or a static body, even kinematic body. And here it says, if the density is non-zero, it will be dynamic. And I guess in our case, we can simplify it and just say, hold on, is dynamic. And the density was a property of what? Of the shape depth. Shape depth, there we go. Polygon depth, density is dynamic. If it is dynamic, then it's 1, otherwise it's 0. Okay, now I think this should do. Now let's go into the collider, and what I want to do here is add a debug method for drawing the collider to the screen. And for that I will need a texture, and I will just create a private static read-only texture. Let's call it debug texture. And then I will create a static constructor where I will instantiate a texture. Oh, I need a graphics device for that, right? Forgot. But I think you can just, I think graphics device actually has, no it doesn't. Well, doesn't matter. Then we're just gonna pass the texture here. That's fine. And now we basically need to draw the texture where the shape is. And let me just make sure that we have fixed rotation set to true. Yep, okay, good. So now let's say, oh, we need to pass the sprite badge as well. And with this sprite badge, we can then draw the texture. The drawing bounds on screen, yep. Whoops. So we got the position. Hold on. We do have the position. We can get the position from the body, but we also need the width and the height. And I guess we can use the compute. This should be... Get local point, get mass, blah blah blah. We use the shape. Oh, hold on, I think in the example, they actually... No, they just output the position, but not the width. Too bad. Well, I guess... Hold on, let me test something here. Just for testing purposes. Whoops. Shape as polygon. Shape. How do I get the size? Get OBB. Okay, I guess since we're never going to change the size of the collider at runtime, we create it once and that's it. I think we can just simply, yeah, let's do it like that. Hold on. We can go into the physics manager here and we pass the size here, right? And then here we say set as box and just pass the size. I will simply make sure to pass the size over to the collider and make sure that it's immutable so that it's consistent. Oops. Ah. And now we can also... Oh, actually, I think that's good. Well, actually, let's create a property here of type rectangle and call it bounding box. It'll return a new rectangle and the X part will be position X, position Y, and then size X, size Y. But those are all floats, so we need to cast them to integers. If we just cast them, we will always round them down basically, or yeah, so let's actually round them. So let's say math round. And actually, I'm going to go into my math util class here and create a utility method for that. there, just for convenience. Oh, whoops. Collider, there we go. It's in a different namespace, so add a directive. There we go. Oops. And there we go. So now we can just use this bounding box property. Pass a color. There we go. This should be okay. Yep. And I think we can test this. Let's go into the MonoGame class. And right up here, I'm going to create a private static read-only texture. I guess it doesn't need to be static. Call it debug texture. Here we go, and then in the load content method, I'm simply going to go debug texture, new texture, pass the graphics device. Width and height will both be 1, it will just be stretched. Oh, yeah, obviously it can't be read-only if I initialize it in a method. Yeah. And now I'm going to create a field of type physics manager. And initialize that, I guess, in the initialize method. Oops. Ah, what's wrong? Gravity, let's just say X obviously 0, and here just say, I don't know, 10. Let's take a look what values they used in the example. If I find it. Actually 10 as well, but negative 10. So let's use that as well. And then in the update method, we need to call the update method of the physics manager, pass the game time, there we go. And then in the draw, oh, right, we need to create a collider. Let's just call it test collider. And in the, where is it? Initialize method, we're going to say collider, test collider equals physics manager, create collider. transformable. Okay, right. It's just pass null. Mass will be, I don't know, 10. Size will be 20 by 20, I guess. Dynamic, true. And if we did that correctly, what's this? Oh yeah, pass the size here. Inconsistent. Oh yeah. Here we forgot to make the interface public, so it's inconsistent in the accessibility. So that's it. And if we did that correctly now, we should see... I mean, I don't know, still don't know the conversion between pixels and meters, but we should see a box falling down. Object reference not set. Transformable was null, yeah. You don't say. Okay, let's just skip this one now. Transformable was small r, so what? Oh! Yeah, okay. Sorry. What are we gonna do here? So basically the idea here was that the collider is always attached to some sort of object. So that's why I added this parameter here of type iTransformable. So I guess let's just go create a class and call it test object. That implements this interface. And for now, just for testing purposes, just make it an auto property and then go here. And here say there, and then pass that here. And I guess now that I implemented this, I can remove this comment here. There. Oh, we forgot one thing. In the game class, we need to... Where is it? First of all, we need to actually draw the collider. So where's the draw method? There. Let's just go down here and say test collider, debug draw, and pass the debug texture. But we also forgot to actually set the data of the texture. There. Just pass a color array. Actually, we can just go. There. Of a single pixel that is white. Let's actually... Let's go back into the collider. Here. I want to pass a color here. so that each drawn collider can have a different color. And then here I'll just pass color, I don't know, red, so it sticks out. Okay, there it is, but I don't know if you've seen it, but it actually floated upwards because of the negative gravity. So I don't know why in the example they used a negative value. Where is it? There. So let's just use, I don't know, 90. And now it should be, well, actually, maybe let's go like 450. So now we should see a red box falling down. Yes, we do. There it is. And it gets faster and faster because of gravity, obviously. So yeah, that's working. So let's make this 90. There it is. It's falling. Perfect. Okay, so now that we know that this is working, we can actually optimize it. First of all, I want to implement a service locator pattern for all sorts of game services. And the physics manager, I think, will be one of them. And what I mean by that is just a game service in terms of like a very basic component of the game that will be referenced a lot by other objects. And I think the music is kind of annoying. Let me switch to something else. I think the music selection last time was way better than it is this time. I don't know. But anyway. I'm actually not sure if we need to dispose of the objects, of the physics objects, after we don't need them anymore, because they might actually use unmanaged resources. I'll need to check that. Let me see. Let's see if the body implements the iDisposable interface. Yes, it does. So we may have to dispose of them. We actually may want to make the physics manager disposable, so it can get rid of all of the, well, disposable objects. So I assume the world is also disposable. Yes, it is. So maybe, let's not care about that for now. Let's keep it in mind and do that later. Because if we don't do that, we might end up cluttering the heap, the memory. Because if the objects here, like the world and the bodies in the world, use unmanaged memory, and it doesn't get freed by the garbage collector automatically, then yeah, we might end up creating memory leaks, but let's not worry about that for now. Let's worry about optimizing this. So actually, let's delay the service locator stuff and actually look at this. So this is okay. Now, what about the bounding box of the world? How am I supposed to know beforehand how big the world is going to be? Let's just say here, pass a rectangle and say world bounds. And then we'll just pass the values here. Actually, left. Oh, it's the lower bound. Okay. So the lower bound would mean, yeah, left is correct, but here it would be bottom. The upper bound would be right and top. So we pass a rectangle here and we use that rectangle to determine the bounds of the physics world. So that's okay. I guess we could... Nah. Oh yeah, let's make this nullable and go up here. Whoops. And create constants. Default world bounds left. There. Lower. I guess it should be negative, right? So bum bum. Yeah. And then if a null is passed here, we'll just say world bounds oh. Hey. Am I not using C#8? What the heck? Never mind. Oops. World bounds. Wait, that's not correct, is it? Oh, right, the X position is okay. And then the width would be upper X minus lower X. go. So this is just a default setting if null is passed. And actually, let's make this. So if we were to completely omit this argument or pass null, then it would use these default values. And oh yeah. Now, because it's nullable, I need to reference the value property. There we go. Create a world, blah, blah, blah. That's fine. I'm not sure if we're ever going to need to set the angle of the collider. So basically make it possible to rotate the collision box. It may come in handy when we like create boxes. I mean, actual crates that we may want to like kick around in the world or something. Then it would be cool if they actually, yeah, if the angle was actually dynamic and not just fixed. But I guess for now it's okay. Oh, hi there. Hi, I didn't notice you were streaming. What did I miss? Actually, not much. We didn't make that much progress today because I had to get back into Box 2D. The original plan was to use Farseer for the physics, but there's this problem with the Farseer NuGet package that it uses namespaces and class names that are identical to the ones in MonoGame. And it creates ambiguities, and so you would have to use a assembly alias, and it didn't quite work out. So we used a different NuGet package for Box 2D instead, and we just implemented the basic physics, and it's working. And yeah, that's it. So let's make these values constant. I just put them in constants. Velocity, iterations. So we just basically implemented a physics manager that's responsible for handling the different physics objects in the world, and a collider class for wrapping the body and shape that are created by the physics engine. And just for testing purposes, we created a method for drawing the collision boxes. And there is one, and hold on, why is it not falling anymore? I think because we may have messed up the world bounds. Oh, this should be okay. Oh no. Should it? Wait. Is this not correct? For X, for Y. Now it should be the other way around. I think. That changed something else. Hold on. I think I'm misinterpreting these bounding values. Yeah, now it's working again. So... Anyway. Let's just do it like this. Factor 2, lower, world, bounce, factor 2, upper, world, bounce. Oops. There we go. Oh. And it should do the exact same thing. Oh. Oh, come on, what's... Oh, I didn't... I made them nullable, but I didn't... Okay. Whoopsie. There. Now it should do the same thing. Yeah, there we go. Working fine. Now we need to add this iTransformable interface as an argument here. Or maybe make this private. So now we have a reference to the object that the collider is attached to. And we can pass that here. And that's fine. And for testing purposes, maybe let's create another collider. Let's call it test ground. Set the position to something like, I don't know, 10 and 300. So that it's way down on the screen. And then create a collider for that. Come on. There. Ground equals physics manager, create collider, pass the test ground object. The mass will be, I don't know, 10 or 100 since it's the ground. The size is, say, the X is 400, Y is 60. Dynamic, no. It's not dynamic, it's actually static. And then here in the draw method we will debug draw it in a different color, let's say green. And if we did everything correctly, then we should see some collision going on. Okay, it does collide, but for some reason the position is off. So I think that's just because it's actually where it's drawn is different from where it's actually simulated in the world. And obviously the offset is exactly the size of this round object. So you may have to invert the vertical position or something. Yeah, I think the X position actually refers to the center of the body. Here, position, we get the position from the body, but I think it actually refers to the center. So we may have to subtract half of the width and half of the height respectively. And this may already be it, if I'm not mistaken. Maybe not. Maybe I should debug it. So the collision is working, it's just for some reason the Textures are drawn not where they are supposed to be drawn. Let's again try size divided by 2. Oops. Quite a slow stream today, but that's okay. Ah, that's not it. I must have overlooked something. Get the position from the body. I'm pretty sure it's the center. For the bounding box, it shouldn't actually be the center. Or did I just... No. Not sure. This should be okay. It's just that I think the point of reference is a different one, so position of the body, hold on. Create shape. Nah. Oops. But actually subtracting the size should be correct. Or half the size, that is. Oops. And then we're still off. If I subtract the entire size, but that doesn't make sense. That doesn't make sense. Why is that? Size. I guess maybe the simulated size is not actually identical to what we set here. Or maybe... Nah, it's fixed rotation. Look at the example. Wait, do we... Yeah. I don't know what's wrong there. Ah, come on, this can't be. What's going on there exactly? Why is it off? I mean, it doesn't make sense here to subtract the entire size. I mean, subtracting half the size should be correct, but it's not. Assuming that the center of the body, that the position is actually the center. So because for rectangles, the x and y coordinates are not the center, they're the upper left corner, so we would have to translate that and subtract the size. But apparently that's not it. Very weird. Okay, that's suggesting to just store the size separately, which is exactly what we're doing. So Jacob, do I pronounce that your name correctly, Jacob? Hopefully, I don't want to butcher anyone's name. Do you maybe have an idea what's going on here? I don't know why it's not the visual representation does not match the simulated physics. So for some reason it's off. I don't know why. Should be fairly simple, but size X. Round, that's fine. Hold on. Oh, I think what's going on here is oh yeah, I think I know. Hold on, let me test something. I should have thought of this earlier. It's read-only already, but it can't be read-only. I have to make it, give it a setter as well. Oh, I'm not calling the update method, so in the physics manager, I guess. Or for now, let's go here and say in the update method, where is it? Here. I'm just going to say test collider update and test ground update. Okay, that's not it, but hold on. For the bounding box, we use the current position. Oh no. For a second I thought here we were using the position from the transformable, which would never update. But that's not the case. We actually use the position directly from the body. Huh? Or maybe there might be a different reason. Hold on. This might be actually correct. First of all, let's try increasing the iterations, but I don't think that's it. Nope. But I think actually for performance reasons, Box2D uses like a small outset for the shapes. So hold on. I think. At least I think so. No, that's not it. Ah. So either I'm kind of miscalculating the draw position, which I don't think I am because it's fairly simple. Or maybe there's some sort of tolerance value around the actual colliding shapes. Let's just remove this here. Oh, we didn't specify the center. Maybe that's it? Let's try omitting this here. See what that does. Oh, that's not it. I don't know what I'm missing here. It must be something very obvious. They use fixed rotation. So when I was working on a physics simulation in a different project, I had a similar problem, and the cause there was that the rotation was not fixed. So the actual simulated colliders were actually rotating, but the rectangles that I draw on the screen are obviously not rotated, so it was kind of off. The rotation wasn't matching. But that's not the case here because the rotation is fixed, so that can't be it. I don't know. We set the size here. Where is it? Here, set its box. Wait. The extents are the half widths of the box. Ah! That's it! Oh my. Oh my, how did I miss that? That's why it says HX and HY, okay. Okay. That's embarrassing, but okay. So, that means we would have to here basically if we pass the size here. but it expects the extents. We should here divide that, right? And then here, not divided by 2. Okay, it's working now, technically, but now I'm missing something else. My position. Oh wait, I do have to. Yeah, okay. Finally, okay. Sorry for the mess, but sometimes math is hard. Okay. Also, you gotta know the library that you're using. And I'm using... Technically, I'm using... No, I'm not using Box2D for the first time. I did use it a couple... I think a year ago? Or 1.5 or 2? I don't know. But in the last project, I was actually using Farseer instead of Box2D. It's similar, but not the same. Okay, so that's working now. So we got colliders working. I guess technically we don't need to store the shape. Anyway. Here, let's say if transformable not equal to null. Okay, so whenever we create some object that needs to collide, or that needs to factor in collision detection, we need to give it a collider, and we need to create that collider by calling the create collider method from the physics manager. And the physics manager should then keep track of all the colliders that are in the simulated physics world, and also remove colliders whenever objects are destroyed. Like, for example, if there's an enemy and I kill the enemy, then the collider should be removed from the world so that it no longer needs to be simulated and take up performance, and also no longer collide with stuff. So we need a way to remove colliders whenever, an object is destroyed. What we could do is give every collider... I was thinking about giving every collider a unique ID. So that we can address them or reference them by ID. Or do we need that? No, I guess for now it's okay to just go I guess we could have a method destroy collider where we can pass in the collider to destroy so that it will be removed from the simulated physics world. First of all, if someone were to pass null, that's nonsense, so throw an exception. And the collider has a body attached to it. Hold on, let me check. World, destroy body, and here we can pass the body. So I guess we could also implement the disposable pattern in the collider. That would also work, I guess. So basically that the collider implements the iDisposable interface, and whenever we no longer need the collider, we just call the dispose method. That also makes sense. I guess it would be even easier. I mean, I guess we can go with both. The easiest way now would just to be to expose the body as a property, like this. Then go here and just say collider body, and boom. Then the destroy body method would make sure that the body that is simulated gets destroyed. But I'm not sure if this is actually practical. So let's say we have an enemy and the enemy is killed, so it needs to destroy all of its colliders. I guess it will have a reference to its collider, so you can just call the destroy collider method, pass the collider, and that's it. I think that's fine for now. I guess. Yeah. Okay, so now we have this weird test object that doesn't do anything but have a position. But anyway, so I guess the player will have to need a collider. So let's go into the player class here and say public collider get. It will only have a getter and it will be a read-only property because it will never change, I guess. Or maybe it should have a private setter for setting it to null if we need to. Let's see. Let's go here into the constructor and say collider equals, oh, we need a reference to the physics world. And that's where the service locator pattern might come in handy. Or we could just have the physics world be property of the game class. That would be fine too. But I guess the service locator is actually not bad. Okay, let us implement a service locator pattern. Just for the heck of it, because we're gonna need it anyway at some point. So let's go here in the core namespace. And let's call it game service locator. And it's going to be static. I'm not too big a friend of static classes because obviously there's no way to abstract a static class, but in this case for the service locator I guess that's fine. So we don't have to pass around an instance of the service locator, or we could make it a singleton. That's fine as well. I guess singleton would be okay. I guess we'll make it a singleton. I'm also not a big friend of singletons, but for a service locator, I guess that's fine. Let's see how it works out. So it will just be a simple implementation of the singleton pattern here. And a fairly simple way to achieve this is this. There. So basically, oh, this needs to be static. No, yeah. And this needs to be static as well. So we have a static property with only a getter, and the getter checks if the instance is null. If it's not null, it will just return the instance. Otherwise, it will create an instance of game service locator, assign it to this instance static field, and then return that. So basically we have lazy instantiation going on here. Now, let's have a method register service or game service. I hope one day you will make a version of Terraria. It would be epic. I was actually thinking about that, but it requires a lot of work, I think. It's pretty cool to have like a world generation algorithm going on. It's actually pretty fun to actually implement that. But I don't know if I have the stamina for a project like that. But it would be a great idea. I mean, you could do it in a smaller scope with not too many different terrains and not too many different tile types, and just keep it simple and then maybe extend it over time, I guess. I guess it would be a possibility. But I was actually fairly recently thinking about that. No, that's fine. Oops. What am I doing? Register game service. Oops. Dictionary. Let's add a null check here. Can't do a null check because T is not constrained to be a class. T could technically be a value type, but anyway. Let's add a constraint here. There we go. Now, if we already registered a service of the specified type, then we need to throw an exception. So if services contains key type of T, throw new, let's just throw an exception here and say service already registered. Otherwise, oh, guess we don't need this. Do we even need to have this? Do we even need generics at all? So I need to cast it. Oh. Oops. Yeah, and these are redundant. So what I'm doing here is now I have a class with a singleton pattern, so there will always only be one instance of this, and I can register a service and here specify both the type of the abstraction, like an interface, and the type of the implementation. Then pass the actual service, the object, and then it will be added to this dictionary of services. And when you call get game services, you specify the type of the service that you would like to retrieve, and it will look up in the dictionary if there is actually a service registered of that type, and if so, it will return it, and otherwise it will return null. So this way we can do something like let's go here, game. We can do something like oh, there is already a service container. I didn't know that MonoGame actually already has a service container. But anyway, let's just use ours. Or maybe, I mean, if there already is one, let's check it out. Ah. Yes, the same thing. Add service, get service. It's the same thing, so we could actually just use that. Because I think the actual game may have services. Okay, so never mind, then we don't need that actually. Okay, so it was a great time, bye-bye. We don't need that. MonoGame already has that. I didn't even know that. I guess you learn something new every day. So instead, I have an interface here for the game class. Let's say game service container. Get gamer. Well, let's just call it services. And now let's make our game implement that. There we go. And that should already work because it already has a services property. And now we can just go here in the initialize method, and instead of having this physics manager field, we can just say services, add service, and pass the physics manager. So now it registers a service for the type physics manager, and I think it's actually better to use an interface as the service type, so you can swap it out at any time. So that's why I had two type parameters in my implementation. So the problem now is when I'm somewhere here in the player, for example. Oh, let's just pretend I'm somewhere else in the code, and I was to get the service. It'll always be of the concrete type physics manager, but I don't want that. I want this to be an abstraction so I can swap out the physics manager in case I need to. So that's why I'm going to create an interface. And I guess simplest way would be actually to delete this. Go here, physics manager, right click, quick actions, extract interface. There we go. That's perfect. That's exactly what we want. And now here I can specify the type to be physics manager. There. So now from somewhere else in the code I can go services get service and use the interface type, and that means I can just swap it out here at any time without affecting the rest of the code. There we go. Oops. And I don't know yet how we're going to handle this update method. If it's just to be called directly by the game. Anyway, let's go back into the player, and I guess we can just in the player constructor just pass a reference to the game. And then go here, game.services.getService, iPhysicsManager, create collider. Transformable would be this. We need to actually implement iTransformable. And we already do, because there's a position property. The mass of the player, I guess it can be hard-coded, or not hard-coded, but a constant. I don't know what a good mass would be here, let's say 10. Size would be, I guess, the size of this. No, not the size of the sprite, because the sprite is a fair chunk larger than it actually should be. Say X 20 and Y 40, maybe. is dynamic. Yes, it is dynamic because it moves. There we go. So now we have the collider. And in the update method, or hold on, I guess in the collider I'm already, yeah. Not sure if I want to do this here. We may want to do it the other way around. So basically what I thought here is that every time the collider gets updated, we should set the position of whatever object is attached to the collider to the position of the collider. But maybe it would be smarter to just go into the update method of the actual object and then do it the other way around. So that way you would have more control over it. Let's just comment this out for now and go to the player. And in the update method, I'm going to say collider. Whoops. No. Position equals collider position. So I think technically now our player should already fall down when I start the game. Not sure, I may have forgotten something. Oops. Oh, we need to pass the game. This. Null reference. Object or not set. What's not set? Oh, I think because get service probably returns null. And that's probably because no, we create the player in the load content method. Maybe let's do this in the constructor just to be sure. Oh, right. This is just testing stuff. It's going to be removed anyway, so it doesn't matter. Yeah, the player's already falling down and it's actually hitting the ground. So right now I can't move because the position of the collider always overrides my own position. Or does it actually? Anyway, now I'm stuck in the ground because here in the player I just simply made I just set the size of the collider incorrectly. So let's make it a little larger, let's say 80. Yeah, that's better, but not quite what I was going for. Almost. I guess you can't see it right now, but I'll show you in a second. There we go. I think we can even move it down a little more, so let's go as 64. Yeah, that looks good. So now I can't move, yeah, because the position is always set to the collider's position, and we don't actually update the collider's position. But that was a problem that I already addressed or already talked about in the last stream. We ignored it for the last stream just for the sake of getting something done. Instead of setting the position directly in the move method, we would have to actually apply some force to that collider. So let's remove this velocity here. Oh. And instead, we will have to set the velocity, but never mind. Let's just say collider. Oh, we need to actually create a method for applying force to the collider. So and I guess we can determine, or I guess for the force we can just use a vector 2. And then we should be able to do something like body, apply force. And maybe I should create some sort of utility method for converting MonoGame vectors to box 2D vectors, because it's really annoying that I have to do that manually all the time. But for now that'll do. Point. I guess the point is where the force is applied. And I guess it will just be the center. So let's say bounding box center. Oh yeah, it's a point. Okay, let's go vector 2, center, bounding box, center. There we go. Then say center X, center Y. Oh, that's actually a point. Okay. Well, I need to take a sip of my soda here. And there we go. Okay, I think that's already it. But I think for applying force, it's basically a constant force. Let's just try it. Let's just say collider, apply force. Now we need to factor in the direction. So let's just say whoops, direction. Dear. Oh, we already have that. So we can just go new, then direction. Let's say 100. And the Y force will be 0. So we will add a force of 100 whatever, Newton or whatever, in the X direction, either negative or positive depending on whether it's to the right side or the left side. And I think probably 100 is way too much, and we will just shoot our player into oblivion. Let's just see. Okay, it's not doing anything. Oh yeah, because hold on. Why is it not applying the force? I think here we should say just say size divided by size multiplied by 0.5. Is there no overload for? Yeah, there. This may have been it, but let's see. Oops. Still not moving. Why is it not applying the force properly? Maybe let's just go with a really ridiculous amount. 10,000. Still not working. But why? It should be applying the force. Collider, where is it? Let's check the reference. Okay, that's cool. That's an actual executable, like form application for testing this. Let's go into the box 2D documentation. Forces. You can apply forces, torques, and impulses to a body. When you apply a force or an impulse, you provide a world point where the load is applied. A world point. So I guess that should just be the position. Let's just go with the position here. Didn't do the trick. Why? Applying a force wakes the body. Sometimes this is undesirable. For example, you may be applying a steady force and want to allow the body to sleep to improve performance. In this case, you can use the following code if it's awake. It should be as simple as calling apply force. Why? What is it? Am I maybe? Okay, hold on. Maybe. No. Force. Maybe it's not awake. Maybe let's set a breakpoint here. I don't see why it wouldn't be awake, but this collider body. Sleep time 0. Apply force. Should be correct. Oops. Excuse me. Just had to go get something to drink. So why doesn't this work? I'm constantly, when I press the button, I'm constantly applying force. but for some reason it doesn't do anything. Could there be friction? No. No, I don't think so. Because when he's still in midair and not actually touching the ground, it's also not working, so that can't be it. Apply force. Shouldn't be. It should be fairly simple. Maybe it's because of the mass. But then it should work if we set it to a ridiculous amount here. It doesn't do anything. Ah, it does. Okay, so it is friction probably. Or the mass. Okay. So now we can push stuff around. Oh, okay. Physics are working, that's good. But that's not quite what I was going for. Okay. Why is a mass of 10? It's just 10. Why does it make such a huge... Why does it have such a huge impact? 10 should... It's in kilograms, right? Pretty sure the documentation said the mass is measured in kilograms. So basically we say our player is 10 kilograms, so I guess he's a lightweight. So if we want to keep this fairly realistic, let's say 80. Now, and I think the force that we apply is actually in Newton, but I'm not sure. Let's see. Does it tell me here? Let's look up box 2D. Forces. So I'm looking it up on this website here. So obviously this is C++, but it's the same thing. Linear movement. Alright, it's because it's gradual, right? So we need to apply it over time. Maybe let's go with an impulse. Does this actually expose methods for impulses? Yes, apply impulse. So let's also have a method here. Apply impulse. Impulse. And I think it also needs a point of reference, yes. We can just say position X and position Y. There we go. Ah, why did I just start it? Layer, apply impulse. So this will basically set an immediate force that doesn't have to build up over time, but still doesn't do much. Oof. Okay. Let me just see. Let me just look something up here. I mean, technically we can also just directly set the position and then simply work with, yeah, just calculate the new position. But that would kind of defeat the purpose of the physics engine, I guess. Melon, I'm still working through the first video. Great to see you continuing on so quickly. Yeah, hi. First of all, hello there, and welcome to the stream. I don't know how long the stream will actually, how long I will be streaming, because it's actually quite late here. But yeah, thanks for watching and enjoying the videos. We're working on some physics stuff here, and we're not making progress as quickly as I hoped, but it's okay. I mean, last time I was working with a physics engine, it was Farseer, and it was a couple months ago. So basically we want to apply a constant force to reach a specified velocity. So yeah. Now let's just look something up here. Box 2D. Nah. Apply forces into D. Yeah, I know that. I just want to... I mean, it's weird that we have to specify such a high value because our player is just 80 kilograms. So why do we need such an amount of force to move him? I mean, maybe he's just terribly lazy, I don't know. But it's probably... let's try something here. Oops. I don't have that. Let's try something else. Oops. Ah. Let's actually go with force. What's wrong? Oh. Oopsie. Nah, I mean, that makes it even less. I mean, speed is what, 200? 100. I mean, I don't like this anyway. It should be like this. This is actually... But why do we have to use such a high value? I mean, obviously there's friction going on now. What happens? Hold on. It's really dragging. But the cool thing about the physics engine is that we can actually do something like whenever I swing the sword, I could make it so that basically that this box here, if we hit it, that it actually is knocked back and flies off. We can do something like that very, very easily. As soon as we figure out why the forces behave so awkwardly. What mass did we give this ground object? $100. Let's give it a mass. Yeah, 100 is actually okay. It's 100 kilograms. It's actually nothing. So that should be fine. But let's try something. Physics manager. This should be a friction. Yeah, there it is. Let's just set friction to 0 for now. Yeah, that already makes a difference. Where am I? Did I fall off? No, there I am. Whoa, 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 whoa. There we go. But I guess that's okay. I just don't know what this is measured in. Player. Let me check something. The World Center. Let me try something here. Whoops. That's the same. So I guess we can use the speed for the impulse value. But I don't know what this is measured in. I guess we can just directly set the velocity. That will also work. Yeah, let's try that. Here, I'm just simply going to say yeah, okay. I don't want to. Okay, hold on. Vector 2. Oops. And let's just directly set the velocity. I mean, obviously that doesn't simulate physics as well. It's just directly setting the velocity, so... Oh. So that obviously works much cleaner, but it's not, I don't know. Hold on, we need to, but now we set the speed to 1000, which is a lot. So let's go 200. I mean, I don't know, I guess for a pixel game with retro graphics like this, it makes sense to have this immediate response. But we never actually set, well, we never actually set the velocity back to 0. Oh yeah, no. Okay, that's not gonna work. Yeah, I guess what we can do is simply, we don't actually, now that the collider has a velocity property. We don't need this velocity field here anymore. And there. And we can instead simply say collider.velocity. There we go. And now it should work as it did before. Yep. Great. So I don't know. You can use forces and have the physics be actually simulated properly, or we can just directly set the velocity like this, which gives like an immediate response. And I think for a game like this is actually probably even better. I don't know. But now that this is working, I guess we could technically implement the jump. But it's rather late. Maybe I may want to call it a day. But I'm actually excited that this is now working, so I'm really want to like actually use that. And whoa. We should actually increase the gravity a little bit. Let's say 200. Oh, okay. Up. Yeah, obviously here if we move, we don't want to always set the y velocity to 0. It should actually be the same as it was before, like this. Oops. There we go. What happened there? What's going on? Okay, that's weird. Why is it doing that? Seems like there is a collision here for some reason. And he gets pushed up because he's inside of the collision box. It's funny. But it's only if I walk to the left. Oh. What am I doing here? That doesn't make sense. It has to go here. Oh no, hold on. Speed multiplied by, yeah, that's it. I don't know what I was doing there. Yeah, okay. Yeah, now it's working. Okay. Yeah, let me think. I may have a couple more minutes to spare, but then I really need to call it a day. Okay, so I guess we can implement the jump. And I guess for the jump we can just apply an impulse. So let's completely ignore the animation for now and just say and also let's completely ignore whether or not the player is currently grounded. Let's just say collider, apply impulse up times, let's say 2000. For some reason, oh actually, no, hold on. No, it should be correct. Doesn't contain? Oh, it doesn't actually have one. Ah, it's called unit Y. Unit Y is a static property that returns a vector with components 0 and 1. Now in the player controller, let's see. Oh, actually, it's not else if. So if previously the space key was not down and now it is down, we'll call the jump method, which should give us an impulse upwards. It's not doing anything. And it's not doing anything because I'm setting the velocity directly here in the update. No, I'm not. Let's just go with a ridiculous value here. I want to see if this is actually called. Yes. think the velocity may be overwritten somewhere. Oh. Needs to be negative. Basically what we're doing now is we're pushing him down. Still not doing anything. Why? Why you no jump? Oh, he does actually jump. He just immediately falls down again. Why does it require such a huge amount of force? I don't get it. I mean, it works, but why do I need to use so ridiculously high amounts or values? It doesn't make sense. Okay, I don't get it. I mean, again, we can just use velocity and work with that. But it's weird that we have to use such huge amounts. I don't get it. It may be the conversion from pixels to meters here that messes it up. That's probably it. But I haven't found yet a way to actually set the pixels per meter or something. Yeah, that's probably it. And in Farseer there was like a static property or something in the world, I think. In the physics world, we could just set the conversion values. I don't know how that works here. Get body count, that sounds terrible. Let's look it up. Blah blah blah, that's not what I'm looking for. Suppose you have a sprite for a character that is 100 by 100 pixels. You decide to use a scaling factor that is blah blah blah. Here the scaling factor is what you set your decision on. Not Godot. Not Unity. Is it maybe in the example here? I guess I'm better off just checking it myself. Like in Farseer there was a class called, I don't know, convert units or something, but in Box2D there's not. Settings. I guess we're onto something. Force scale. Force scale. Velocity threshold. Ah. Math, blah blah. That should be settings, that's correct, but assigning fixtures, blah blah, gravity, damping, fixtures, joints. Never do 1-to-1 ratio. Box2D doesn't like large numbers. You need to map in virtual pixels, blah blah. Don't use pixels per meter. That's a different thing. I don't know. Ah, the density. I forgot about the density. Obviously, if we have a density of 1, it basically our player is like kind of like a ghost with a low density of 1. So hold on. Here in the create collider method, going to add a density argument. Oh yeah, that's what I used the isDynamic for. Well, I guess I will make this nullable. Or I can also create a separate overload. Let's remove this and instead say density. I have a separate overload. Wait, if it is dynamic, it's 1, otherwise it's 0. So that way we can still use the old logic. But let's see. In the player, in the constructor, now let's actually pass density. Let's say, I don't know, 10? 10? Hey. That should be okay. There should be 2. Oh, yeah, right. Because the interface doesn't expose that same method. Player. There we go. Now that it has a higher density, I guess the force should be have much more effect, or maybe not. I thought this would be it. Box 2D density. Density. The mass depends on density and area. Okay, but I did set the mass directly. So I guess it doesn't make a difference, actually. Dang it. Okay. Actually, true. We should be good actually. Okay. Well, I guess I have to play with these values a little bit and find out what works best. But this is ridiculous. I can't use values as high as these, it's just... But apparently, I mean... Now he's jumping fairly high. And if I set the density higher... Yeah, I mean, that makes sense. If I set the density higher, then the force won't do as much, yeah. Okay, no, that makes sense, okay. A density of 1 should be okay. But I guess what the problem is that the physics engine works in meters, right? So, but I work in pixels, and so that means when I create a collision box, a collider here of size 20 by 64, so that's basically 20 meters by 64 meters, so that's huge. So I may have to scale that. And I thought there would be some kind of global scaling factor which would make everything easier, but apparently there's not. I mean, there's a force scale, which I guess I can use. Let's try that, and then after that I'll call it a day. for scale. But it actually returns. It's a method that returns a float. That's weird. Let's say 10. Let's see what happens. Not sure if anything happened. Let's use a ridiculous amount here. No, it's not actually doing anything. I don't know if this is actually doing what I think it should do, because it's a method that takes in a float and returns a float. It's probably meant for some other purpose. Let me just look up something here. Hold on. I mean, we could just write our own method for converting back and forth from game units to physics units. But in Farseer, there was like just a static property you could set for that, and it was really neat. And I thought Box2D would have a similar thing. Well, apparently not. Let me just actually try one more thing here. Let's make the world a little smaller. I think that actually has an effect. Nope, it just make here now the world basically is constrained to this area here, since it's now 300 by 300. So physics simulation just kind of ends. Yeah, we will have to convert those values. I'll think of something. We can't just work with these values because they're way too large for the physics engine. If we go just with pixels, if a character is like 80 pixels in size, we can't just use 80 for the physics units, because that would be 80 meters. So in the eyes of the physics engine, everything in our world is huge, and that may be a problem. So yeah, we have to include or incorporate some kind of conversion logic. But that's a thing we can do next time. So I think I'll call it a day, or actually a night, and I'll head off right to bed. Thanks everyone. Thank you for tuning in. Thank you for hanging out. And yeah, I guess we did make quite some progress actually. I mean, yeah, I would have hoped that my actual plan was to include the physics engine and also work on the state machine of the player for the different player states as well. I didn't actually get to do that, but well, never mind. So thank you all so much. See you next time. I don't know when the next stream will be. Maybe tomorrow, maybe the day after tomorrow, I don't know. We'll see. But I'll announce it in time. So, thank you all very much, and see you next time. Bye.